Hey guys, welcome back to the channel. Today on the channel, we're going to be taking a look at this Pioneer SX-950. And so specifically, when we opened this up the other day, we saw a lot of burn up resistors on the amp board. So that's a good idea, a good cue that something's going on with the amp board. But just in case, we need to go ahead and check out the power supply section. So we're going to be using our service manual, and we're going to take a look at the voltages on the power supply section. Because if we're putting crap in, we're going to get crap out. So we want to make sure that we've got good voltages there. So why don't you guys come in closer, and let's go ahead and get started. All right, guys, so here we are back at the receiver. And so this right here is our power supply. And so this is our power supply board, this is our protection, and this is our phono. And so we have 15 pins here. And so one starts here, and we go all the way down to 15. So we're going to be looking at the voltages on these 15 pins. 2 of them are ground, 1 and 12, so we know that's going to be 0, but the rest of these should have voltages at it. And so we can find those voltages in the service manual, and so I've gone ahead and written them down and got those ready to check across this. The other big thing is that we're going to be plugging this into our dim bulb tester, and so when we do that, the voltages may be a little bit lower or slightly off, and that's okay. It's to be expected. So now that we have it plugged into our dim bulb tester, we're ready to go ahead and turn this on. But before we do that, let's go ahead and talk about our multimeter leads. So we're going to have 2 leads. We're going to have our ground connected to the chassis of the receiver, and then we'll just have our probe here ready to look at the pins. And so now that we have that set up correctly, let's go ahead and turn on the unit. Make sure that you guys are being very careful when you're in here because now everything is live. We want to make sure our multimeter is set to DC volts, and we can go ahead and start checking pins. So 1 is ground, so we expect that to be 0, and it is. 2 should be around 5.4 volts, and it is. 2 and 3 are connected, so they should be about the same, and it is. 4 should be around 13.9 volts, and we got 13.2, so that's good. 5 should be the same, around 13.9. We got 13.2, so that's good. 6 should be around 51 volts, and we've got about 50 volts. 7 should be 51 volts as well, 51.5, and so we got about 50 volts there, so that's good. 8 should be around 36.5 volts, and we're just a little over 35.5, so that looks good. 9 and 10 should be around that 36.5, and so we got 35.6, so that's good. And at 10, we've got 35.6, so that's good as well. Number 11, we should be at around 28 volts, so we got 27.28, so that's good. Number 12 is ground, like we talked about, so we shouldn't have any voltage there. 13, we should have negative 13.5 volts, and we've got 13.1. 14, we should have negative 51.5 volts, and we've got just shy of negative 50 volts, so that looks good. And then pin 15, we should have negative 19 volts, and we got negative 18. So all our voltages, guys, look really good on the power supply section. So our problem isn't with the power supply section. And we kind of knew that anyways, but we could have had multiple problems, so we want to rule that out. So regardless of what the problem is, we're still going to rebuild this power supply section. I think it's always a great place to start anytime you're troubleshooting a unit, to start with the power supply section. Because, like I said earlier, if you start with crap, you'll end with crap. And this is where it powers the entire receiver. This is where it all starts at. So we want to make sure that we've got this taken care of. So we're going to wind up replacing all the capacitors and the transistors in here as well before we go ahead and start troubleshooting anything else. And while we're back here, we'll probably go ahead and do the protection board as well. So you guys have seen me do that before, so I'm not going to belabor that point. I'll probably do that off camera and then come back to you guys if I find anything unusual that we weren't expecting, or any teaching moments that I think we should teach. So big thing when we change the capacitors, guys, and you'll see me talk about it on other videos, is making sure that we put the capacitors in the correct polarity. So the capacitor has a negative and a positive side, and so we want to make sure that we always put the correct polarity on the circuit board, and usually that'll be denoted on the circuit board by a plus symbol. And so on the capacitor itself, you'll see a stripe, and that indicates the negative side of the capacitor, whereas the long leg on the capacitor will indicate the positive side of the capacitor. So we want to make sure we do that. When we change out the the transistors, guys, I've been doing it a little while, so I know which transistors make good substitutions. But if you don't know, guys, a great resource is that is Audio Karma, and so you can go on there, you can find a lot of the work already done for you. And so you want to make sure you do your research. So when we talk about transistors, I keep saying capacitors. Obviously, capacitors are on my mind. But when we talk about transistors, remember we talk about the pinout. And so I know if you're watching my videos, guys, you'll probably hear me talk about this a lot, but I always emphasize it because we never know when we might have a new viewer on here who's starting out, and so I want to make sure I recover that same information. But the transistors all have a base, collector, and emitter, and so if you're unsure of which one of those pins is either one, you want to make sure that you go to the data sheet on the transistor itself and make sure that you've looked at that and you understand what the correct pinout is, and then you're going to basically put that into the board based on what the circuit board tells you to do. And so if you guys have any questions about that, make sure to leave comments down in the video. I'll be more than happy to help walk you through that or talk you through it or whatnot. But since I've done this before on camera, guys, I'm not going to do this on camera, so I'll go off camera and I'll go ahead and report back once we've got the capacitors and transistors done on the protection board and the power supply board. So we'll see you guys in a little bit. Alright guys, so I've gone ahead and I've changed out the capacitors and transistors on both the power supply board and the protection board, and I just want to go over some things of note before we continue. And so just general advice, and I don't think I mentioned it before, is to work on one board at a time. And so this way, especially if you have a working receiver already and you're doing a recap and you're just trying to restore it or refreshing it, you want to make sure that after each time you work on a separate board or a separate area that you're going ahead and turning the receiver on, making sure you don't have any shorts by plugging it into your dim bulb tester, and also that you're still getting relay click. In this particular example, since we didn't have a relay click, we can't do that. But that'll help you narrow down any problems, or if you've done something wrong, put a transistor leg in the wrong place, maybe a capacitor in backwards. And so that's really good advice, especially when you're starting out, is to do one board at a time. And honestly, it's good advice even if you've done it 100 times, because we're all human and we make mistakes. The next big thing is that before you start just plugging and chugging, fix the problem first. And so this is advice that I'm giving you guys that I didn't follow on this receiver, because I haven't fixed the problem as to what's wrong with this receiver. We know it's something to do with the amp board and probably a transistor or resistor in that pathway. But I went ahead and recapped both of these boards, the protection and the power supply board, without fixing the situation first. And so the reason I say that, guys, especially when you're starting out, is that now if I fix the amp board and it still don't get relay click, or I'm still having issues, I don't really know where my problem is or where to start, because I've already swapped out all these components, and maybe I put this transistor here and backwards. And now it's going to make it a lot harder for me to backtrack and find where I might have made a mistake at. So a really good idea to fix whatever the problem is, get the receiver up and going first before you start swapping out a whole bunch of components. I've worked on these before several times, so I'm pretty confident that I've done these correctly, but anyone can make a mistake, and I'll tell you a story about that now. And so this board here, the protection boards, and actually a lot of these receivers, it's in the 3 series, it's in the 850, the 950, and so it's in a bunch of receivers. And so this is the protection board, the AWM 062. And so when I was starting out, I thought I put all the transistors in correctly, and I had a leg backwards. And when I went and did the research, there was a variant of this transistor, a 945, where the pinout was a little bit different. And so I assumed that the pinout was just the same as it always had been with what I had purchased before in the past, and it wasn't. And so, but I'd already worked on several boards already before checking to make sure that I didn't identify the problem. And so it made it exceedingly difficult for me to go back and check all the components, and I was sitting there scratching my head till I figured it out, because to me everything looked correct when in actuality I just had the pinout wrong on a transistor that I assumed was the same. So it's a good idea, guys, especially when you're starting out, to follow those two pieces of advice I gave you. The next thing we'll talk about, guys, is transistor substitutions. And so I've been doing this a while, so I've made a transistor substitution list of the transistors I like to use in place for others. But if you haven't done that, guys, or if you're just going to be doing one receiver, which is your personal receiver, something like that, make sure you get the schematics and do your homework, and then come into it with a plan already, knowing that, hey, this is the transistor I'm going to be subbing out before you get in here and start pulling parts. That way, the process will go a lot smoother for you, and you'll have a lot better enjoyment out of it and not get frustrated. So moving into the power supply board, there's a couple things I wanted to call out when I did this particular refresh process. And so there was two capacitors that were actually different on the board than were on the schematic. And so one of them was a 1000 microfarad 35 watt capacitor up here, and it was actually changed to a 2200 microfarad 35 capacitor. So if you were parting this out based on the schematic, you may be short a capacitor. So make sure that when you see that, guys, put in the capacitor size that you found on the board. A lot of times what happens is they'll do updates and the service manuals or the schematics won't be changed to reflect that. And so for whatever reason, the engineers thought that was a better choice, and so when they built more of these, they put a different capacitor in it. So that was one of the capacitors. The other capacitor was a 2200 220 10 watt 10 volt capacitor, and it was changed to a 47 microfarad 50 volt. And so, like I said, if you see something different on the board, go with what's on the board rather than what's in the schematic. The other big thing I like to do when I recap a power supply, guys, is upsize the voltage. And so in previous videos I've mentioned this, but I'm going to want to make sure I mention it again here, is that anytime we're doing a power supply, guys, it's a good idea to go one step above the voltage that you see in there. So for instance, there was these here were called for, I think, 63 volts. And I winded up putting 100 volts because that's what I had in there. And so you can go up in the voltage, guys, but you can't go up in the capacitance. And so the reason I do that, guys, is a lot of times manufacturers, when they built these, they put a capacitor in there that was just good enough to meet the voltages that might be in the circuit. And so I like to go ahead, especially on the power supply section, and just give myself a little bit of that breathing room when it comes to the voltages that these capacitors may see. And so if you don't have the capacitor, and you can plug in what you have as long as it's equivalent voltage, but I think it's always a good idea to upsize your voltage. Now moving into the protection board, guys, there's a couple things I did differently here. And so like I said before, this protection board is used in many of the receivers. And a lot of those receivers, we install a flyback diode when we restore this board. And so I know it's hard to see here, guys, but I've went ahead and installed a flyback diode across pins 9 and 10 with the cathode side of the diode attached to pin 10. And so this basically just protects the circuit from a rapid de-energization. And so it just makes it a safer circuit without damaging the unit. The other big thing you'll notice is I put in film capacitors here. It's not necessary, but since this board is in so many receivers, I've brought a lot of these film capacitors just for this board, and so I had them, so I did that. And then lastly, guys, transistor matching. And so what I mean by transistor matching, guys, is making sure the gain is similar in a pair of transistors. And these two transistors in particular, we want to make sure are matched. And so I went ahead and I used my transistor tester, and I gain matched these two transistors. And so that's the only two that on this board that we need to match. So other than that, guys, it was a pretty much straightforward process, plug and chug with new capacitors and transistors. So everything went smoothly here, guys. So now we're going to flip this unit over, and we're going to start taking a look at that amp board and see if we can't figure out what's wrong with this unit. All right, guys, so here we are looking at the amp board. And so if you remember on the previous video, we had some burnout components. And so this resistor looks like it's been burned, this resistor here, and this resistor. And so the damage seems to be mostly confined to this right side. So I'm assuming that it's just maybe the right channel is out, maybe a transistor somewhere. But interesting enough, guys, when I hook this up to my dim bulb tester, my bulb is not very bright. So that tells me that I don't have an ongoing short right now. But the damage suggests that we had a short at one point. So my theory is, and I just like to give you guys my rationale, how I think through things, and we'll find out if I'm right later on. But my theory is a transistor, probably one of the output transistors, maybe one of the pre-driver transistors, shorted out, burned up these resistors, and they opened up and no longer connect the circuit. Therefore, there's no longer a short. So if we were to just swap out these resistors that are burned out, guys, I have a feeling what would happen is that the bulb would go very bright and these resistors would begin to cook again. So they would probably complete the circuit and there would be a short again. So most of the damage, like I said, is confined over here. So I'm assuming probably a transistor in this right channel. Now over here there is some char, or some, looks like something happened around the cement resistor at one point. I don't know if that's related to this or if that was a separate issue maybe years ago and it was addressed or fixed. But I'm not sure. But we'll wind up checking this out anyways, because what we're going to do to this board, guys, anyways, is we're going to replace all the electrolytic capacitors and all the transistors on this board anyways. Regardless of what we find, that's what we're going to do to this amp board. Now, what I usually don't do, if they're good, is replace the output transistors. But I have a feeling we're going to run into some output transistors that are bad. Now, I was thinking about how this could have happened, and sometimes what happens is when people are hooking up speakers, they cross the positive and the negative wires, and that can short an output transistor. And so that might be the problem, or there might have been something else, a component that just went bad over time, a resistor or whatnot, who knows. So we'll go ahead, and we have to go ahead and start disassembling this. And so this is very similar. You guys saw me do a 838, and the disassembly is very, very similar to that. So I'm just going to do a quick overview, and then I'll go ahead and disassemble this, and we'll meet back. But there are a couple things I want to highlight. These right here, guys, are diodes, and they're very sensitive. So we got one here and here. They're very sensitive, so we want to be very careful when we take these out because they're known to break. So if you're trying to do this on one of your units, guys, and you see these, make sure you're super, super careful. The next thing we guys have to do is remove this heat sink. And to do that, guys, there are going to be screws on each side. There's 2 screws here and then 2 screws over here. So we're going to unscrew those screws, and then we'll lift this whole thing out, and that'll give us access to the output transistors themselves. And then each one of those has 2 screws holding it in for a total of 8 output transistors. We'll disconnect that, and that will allow us to remove this heatsink all the way out. From there, guys, there's 3 screws on this PCB board, one here, here, and here, and that'll allow us to detach it from this metal bracket here and then be able to move that board out of the way. Then we're going to take out this metal bracket, and on each side of it, here and here, there's a screw as well. And so we'll remove that, guys, and then basically that'll give us enough room to work on this PCB board and go from there. Okay, guys? So I'm going to go ahead and do that, guys, and we'll meet back here in just a second once I've got it disassembled, and we can start testing components to see what is bad. All right, guys, I wanted to show you this, and so it's probably going to be hard to see, but I'll take a picture of this and put on the screen. But remember when I said that this side might have had previous work because I don't see any damage, but there's char on the cement resistor here? Well, when I looked at the output transistors, it looks like this side, the left channel, has been replaced before. And so I was right about that. So these transistors on the right channel are the original ones, and these have been replaced in the past. And so just going off my logic right now, you know, we still haven't troubleshooted anything, guys. This kind of reinforces what my train of thought was, that the problem's probably located on this right side. So we're going to go ahead and remove these output transistors, or at least these screws here, and then we'll continue with the disassembly process, guys. And then when we come back, we're going to start testing these and see if my theory is correct. Now, even though we think that just on this right channel, I'm going to go ahead and test all of these output transistors when we come back, because we need to make sure we're very thorough, because when we do hook this back up, we don't want there to be a short and then wind up having to replace maybe some of the same components more than once. So let me go ahead and finish that disassembly process. All right, guys, so we've got the heatsink out and we've got our transistors. So these transistors, output transistors on this side, are the right channel, the suspected bad channel. This is the left channel on this side, these 4 transistors, and these are the ones that have been replaced. I'm going to throw a picture up on the screen now, guys, so you guys can see the difference between the original and the replaced transistors. The originals were the Toshibas that are on the screen now, and the replacements I'll put on the screen right now. So what we're going to do, guys, is we're going to use our piece of test equipment. And so what I like to use is this Peak Atlas DCA 55. And so I've got numerous different types of test equipment for transistors. This one I find is very accurate, so I'm going to use it. I'm going to do my best, guys, to show you the readout on the screen. But bear with me, because camera work's kind of difficult when you try to do this stuff. So I'm going to zoom you guys out just a little bit. So again, this is the right channel. So let's go ahead and start. So I'm just going to test one, and then I'm going to put it right back in the spot that it was at, okay? So with these TO3 transistors, guys, the casing is actually, I think it's the base or the collector. I can't remember. But when we put it on here, on our piece of test equipment, it's going to actually tell us what it is. So one of the leads is going to attach just directly to the case itself. So we'll just go ahead and put it on there. Sometimes you won't get a good connection and it won't read, so you'll just want to make sure that you get a good connection. So this first one we're putting in, we're going to... And this is testing bad, guys. So if you can see that, let me see if I can zoom you guys in. And then refocus. That transistor is testing as a diode junction. So my theory is looking pretty good right now. But just to be on the safe side, guys, I'm going to adjust the leads on the transistor to make sure that I'm just not getting a good connection, and retest it just to be on the safe side. And so we're getting the same result. So I'm going to go ahead and mark on this transistor with a permanent marker just to show that it's bad, okay? So I'm going to do that, and we'll do that for every single one of these transistors, guys, so we have a good idea. So I'm just going to put an X on it. So we know that one's bad. Now we're going to test the next one, and we're going to do the same thing. I'm going to zoom you guys back out, and from here on out, you guys will just have to take my word on this meter here. So kind of the same thing. We're going to just take one to the case and to the 2 terminals of the transistor and test that one as well. This one's reading as a diode junction as well. I may not have a good I'm just going to go ahead and double check this, because I hate getting wrong answers. Still testing as a diode, so we know something's wrong with that. Go ahead and test this third one. This one's saying we have a short circuit on it between red and green. So where the red and the green is attached, we have a short circuit on this transistor. So that one's bad as well. We'll put an S on that one for short circuit. So far this left channel is looking mighty bad. Had some catastrophic failures in here. And probably one failure led to the next failure. And this is the last transistor, output transistor on the left sides. And this one's testing good, guys. So it's an NPN transistor, and it's testing good. So 3 out of the 4 transistors in this channel were bad. I'm going to go ahead and repeat the process for the left channel, guys, and I'll just let you know what I find, okay? All right, guys, so I just got done checking the left channel, and just as I suspected, all of these output transistors are good. So our problem is in this right channel somewhere, and so we found 2 that were testing as diodes, so we know those are bad, and we found 1 that was shorted. So whatever happened, it seems confined to that right channel. Obviously, we're replacing all the components on the amp board anyways, so it'll probably come out in the wash if there's a component there. However, there's some resistors burned up, and so just like my theories suggested at the first, was that I thought at the beginning of this video I told you guys that I thought to cause that kind of damage an output transistor had to be shorted, and then I talked about why our dim bulb tester was not coming on when we powered on the amp and what could cause that. And so I think that's what's happened in this instance, and the reason that that bulb wasn't coming on is because the short caused a burnout in the circuit, and it probably burned through one of those resistors and it's no longer completing the circuit. So we'll need to replace those as well. So what I'm going to do with these guys is we have a couple choices. We could replace all the output transistors to brand new equivalents, or we can use some old transistors from another receiver that I happen to have lying around, and I actually have some that match the neck transistors on this left channel, so I'm going to use those and put them in the right channel as well. So I kind of looked at on that, but if you didn't have those transistors, there are modern equivalents that you can get, and so it's not cheap. You know, I think they're like $10 or $15 a piece for the transistors. So it's nice. I've over the years, as I've rebuilt units and I've had to swap out some, I've kept the old ones, and so it's nice to have a pretty good amount of old stock. And so as you guys can see, I have these are all my TO3 transistors here, so I've probably got 40 or 50 of them. So it's nice to have a whole bunch of them because you never know when you're going to need them. Now, overall, guys, it's rare that I see a TO3 transistor that actually fails, and so I've seen it a few times, but more times than not, it's something else. So something significant had to happen to this receiver in order for one of those to short out. I suspect that somebody crossed the wires, probably when they were hooking up to a speaker or something like that. Could be something else, and I could be completely wrong, but so far I've been right, so we're going to roll with it. And we'll never know anyway, so we'll just pretend I'm right. That's what I tell my wife anyways. So I'm going to go ahead, guys, and what I'm going to do is swap out these transistors. There is one good one, so I'll save that and add it to my pile. And what I'm going to do, guys, is I'm going to refresh all of these with new seal pads and new thermal compound. And then I'll set this aside and we'll continue our work with the amp board. So let me go ahead and do that, guys. I'm going to do that off camera. You guys have seen that before. But if you have questions on it, just leave them down in the comments below. So I'm going to go ahead and do that, guys. And next up, we'll be working on the amp board. All right, guys, so here we are back at the amp. And so as you can see, I've gone ahead and replaced the output transistors, the ones that were bad, and put new seal pads and new thermal paste on this heatsink. So this is ready to go, rock and roll. So now we're going to start working on our actual amp board itself. So what I'm going to start off with doing, guys, is you'll notice that these 3 resistors are burnt up. And so I think that's what's probably the bad components on this. When the output transistors go, sometimes it'll take these driver transistors with them. But honestly, it doesn't matter in our case because we were going to replace all that anyways. So on this amp board, regardless of what we find, we're replacing all the transistors and all the electrolytic capacitors anyways. So I'm not going to belabor that point and test all those things because I'm going to be replacing them. But I will pull these off and test these just to see if they're open or what resistance value they're still reading, if any. And so just so we know. So we've got these 3 resistors. These 2 on the outside, here and here, are actually 150 ohm resistors, and this one in the middle is a 5.6K resistor. And so this is where having the schematic is really important in the service manual, because if I had to pull these off and look at the color coding, obviously it's so burned up I wouldn't be able to do that. Now I could look over here on the left side of the amp board and look at these, but sometimes they're not always right either. So having the schematic and being able to compare that with either the channel is a good way to ensure that you're getting the right resistor in place. So we'll go ahead and pull these resistors off, and I'll show you guys and talk about on my tester what these test like. So let me go ahead and heat up my solder gun, guys, and we'll come back once I've got these pulled out. We'll talk about that, and then we'll go on to the regular restoration of the amp board and see if we can get a relay click before we put the output transistors back in. So let me go ahead and do that, guys, and we'll be right back. All right, guys, so I've got those resistors out, and so I've got a couple different testers here, but I'm gonna go ahead and throw it into one of my testers, and then we'll see what this is reading. So this one is a 150 ohm resistor. So this one's reading is damaged, no component in the system itself. So obviously we knew that was bad. This one's supposed to be 5.6 kilo ohms. And this one's actually reading at 318 kilo ohms. So that's way out of spec. And then last but not least, we have this resistor that's in this covering. So I'm going to go ahead and take that covering off so you can see what it looks like underneath. So this one's nice and crispy too. This one's supposed to be reading at 150 ohms as well. And this one's reading at 17.5 ohms. So all three of those resistors are bad. So I've gone ahead and I've got the new replacements out. And so when we look at this board, those are the three resistors in line that actually lead to these output transistors. And so I might go ahead and pull these resistors off just for good measure and test them as well and see how we're doing and go from there. But I may, once I put those in, I may just hook it up and see if we get a relay click once we complete the circuit, or hook it up to my dim bulb and see if we still have a short. If we still have a short, then we know that probably one of the transistors, pre-driver transistors, had probably shorted out or gone bad when the outputs shorted out as well. So let me go ahead and do that, guys, and then we'll come back once I'm done with that and then test it out. All right, guys, so I went ahead and replaced these three resistors like I said I would, and I wanted to see if we still had a short, if we were still having problems with the board. So I went ahead and hooked this up to my dim bulb tester and turned it on. As soon as I did that, guys, these resistors started to get way too hot and burn up as well, so I immediately turned it off. So somewhere we still have a short or excessive current draw going through this circuit. So the next thing I'm going to go ahead and do, guys, is I'm going to go ahead and replace all the transistors and the electrolytic capacitors just to eliminate that. And then from there, I'm going to start, I'll test it out again and see if that problem still exists. While I have these transistors out, I'm going to go ahead and test these to see if maybe they're one of the culprits. Once I've done that, guys, I'm going to start pulling some of these cement resistors and resistors in between to see if maybe one of those have gone bad as well. There's also a diode here, a couple diodes we might want to take a look at. And so if going through these other processes doesn't fix it, I'll start looking at those diodes as well. So I'm going to go ahead and start doing that, guys. And so one of the things that I have put together, guys, is an Excel spreadsheet for my transistor substitutions. So I've got a big Excel spreadsheet to where I can go ahead and put in these transistors that are on boards usually or in the schematics, and it'll automatically tell me what transistors sub out. I've been doing it a while, so I know some of them off my head by memory. Like these here, this is going to be a KSA 940. This will be a 2073 probably. These will be 992s, 1381, and a 3503. So, but if you're not unsure, guys, just make sure you do your homework before you do this. So just to kind of summarize, guys, we're going to go ahead and swap out all the transistors and electrolytic capacitors. And then from there, we'll retest this to see if we're still having a short on the dim bulb tester, and then go from there in our troubleshooting and diagnosing. So hopefully we'll find that one of these transistors have shorted as well, but I'm not entirely sure if that's going to be the case. So we'll just go ahead and have to start doing some more detective work and find out. So I'm going to go ahead and do that, guys, and we'll come back here after I've swapped out those parts. All right, guys, here we are back. I've gone ahead and I've changed all the transistors and electrolytic capacitors on this board. And so I also went ahead and swapped out the resistors here. And because I like symmetry, I went ahead and changed these resistors over here so they had identical resistors. And I don't know, I didn't need to do that. These tested fine on the left channel, but I don't know, I guess I'm OCD. I wanted to make sure it matched. So after doing that, guys, when I first pulled out these transistors on this side, remember we talked about the output transistors being shorted, and sometimes they take the driver transistors with them. And so when I pulled those out, both of these driver transistors were shorted, and so I tested that on my Peak Atlas semiconductor tester, and both of these were shorted out. And so that's why we were still getting the signs of a short on the amp board itself. So now that these swapped out, that's hopefully fixed the problem. I also went ahead and pulled the legs on some of these resistors and double checked those and did some more troubleshooting. The rest of the transistors and all the other components on the amp board were fine. So I think we've got this ready to rock and roll. I did want to do a couple important shout outs specific to this machine and one similar to it. And so this board sits on a metal bracket that we took out at the beginning of this, and that bracket is actually pretty close to the back of this board. So you want to make sure that you're trimming your leads on the back here. And so a lot of people sometimes will leave their leads long, and if you do that, guys, you're going to probably cause a short, and then all that hard work you just did, you're probably going to have to redo again. So make sure you're trimming your leads, and it's just good protocol anyways, and it makes it look a lot cleaner and neater in the back, and it's more professional. So the next thing I want to talk about, guys, was, and I didn't mention before, was on these resistors. When you change these resistors, guys, it's not one resistor, you get the correct resistance in there, and it's right. You want to make sure you have the right wattage resistor in there. And so when I talk about wattage on a resistor, that basically means how the ability of that resistor to dissipate heat. And so these on the outside here called for a 2-watt resistor, and this one called, I'm sorry, for a 1/2 watt resistor. These two for a 1/2 watt resistor, and this one would be a 1/4 watt. I went ahead and changed all of them with 1/2 watt resistors, and did the same thing on the left channel as well. But make sure you're paying attention to the wattage requirements of the resistors that you're replacing as well. The next big thing, guys, is even though we went ahead and changed out all the transistors, I wanted to bring this up, and it's going to be really hard for you guys to see, but there's 4 resistors on here that need to be gain matched. And so there are these little resistors here and over here. And so refer to one of my other videos about gain matching, and I think I'd put a short up about gain matching, and if I haven't, I'll probably make a short and just talk about gain matching your transistors, and that's really to make sure you have a balanced left and right channel. The other big thing with these resistors, the old resistors that go in here are 2SA726s, and they're known troublesome resistors that go noisy over time. And if you look on the resistors itself, let me see if I can get a good picture of this. Zoom you in. You'll see that those legs are black. You'll see what was soldered in, and then you'll see that there's black on those legs. That's like resistor rot. I'm sorry, transistor rot. So when you see that, you know, those transistors are kind of suspect. Some of that's just aging. Some of that could be from the burned up process as well for what was the resistors in there. But I see that a lot on these resistors, and these are, like I said, known troublesome transistors. So it's a good idea just to get them out. Even if they're not bad, go ahead and take them out and replace them. And so I did that on this receiver, and so it's good practice to begin with. Zoom you guys back out now. So this amp board should be good to go, guys. And so we're going to power it up on the dim bulb tester like this without the output transistors in there to see A, if we have any shorts, and B, if we get a relay click. And Lord willing, we'll get a relay click. So when we do this, guys, the reason I'm doing this without the outputs in there, guys, is because I don't want to get it all back together and realize that I've done something wrong where I haven't fixed it. So we want to make sure that we're not going to do that. So we're going to go ahead and power it up. We want to make sure that the metal, like these heat sinks, are not touching any metal. The back of the board's not touching any metal. And so that way we're not going to create an artificial short while we power this up. And so if we've done everything right and we fix the problem, guys, we should get a relay click. So I'm going to go ahead and hook it up to my dim bulb tester, and then I'm going to power the dim bulb tester on, and then we can power the receiver on and see if we get that relay click. And there it was. I hope you guys heard that. There's the relay click. I'm going to go ahead and power it down. So that's a really good sign, guys. That means that we should theoretically get some music out of this thing once we hook up the output transistors. So I'm going to go ahead and hook up the output transistors, guys. Once I do that, I'm going to go ahead and connect some speakers and the source, and we'll see if we get some music out of this thing. Now, I haven't cleaned the controls on there, so it might be a little staticky, but hopefully we'll get some clean music, and then we're pretty much mostly there with this receiver. We just got to button up a few loose ends, and then this thing will be ready to rock and roll. And so we brought another receiver back to life, hopefully. So let me go ahead and do that, guys, and we'll see you here in a few minutes. All right, guys, so now we have the Pioneer SX-950 back on the bench, and so we've gone ahead and installed the output transistors. So this thing's ready for a test run. So keep in mind, we haven't cleaned the controls, so it might be a little bit staticky, but I'm going to go ahead and turn it on. Let's make sure we get our relay click and that we don't have any shorts on our dim bulb tester. So if we've done this right, the bulb might light up and then immediately go out, and then we should hear a relay click. So let's turn it on. And there goes our relay click, so that's a good sign. So now I'm going to hit play on this thing, and let's see if we get some good music. All right, guys, so this thing's working. So now we still have some work left to do on this, but it's in good shape. And so most of the work has been done. And so now we'll just have to basically clean the controls, get that freshened up, test the phono section. I'll probably check the FM alignment, and then make sure I change out the LED bulbs, and do a couple other minor things just to get this thing ready to sell and find its new home. So before we leave, though, guys, I kind of want to do a review with you about my train of thought on how we were able to fix this thing and how I troubleshooted it. So what I'm going to do, guys, is bring a picture of this schematic up and bring you guys in closer, and let's talk about what we found when we opened up this unit, and then why we diagnosed it and check the parts that we did in order to fix it, okay? So why don't you guys come back in and we'll take a look at that schematic. All right, guys, so here we are looking at the circuit board of the SX-950. And so what I hope to accomplish here, guys, is kind of give a summation of what we did and kind of my train of thought in order to troubleshoot this problem. So the very first thing we did, guys, is we noticed that we had some resistors burned up. But instead of diving right into fixing the amp board, I want to make sure that you guys realize that we first looked at the voltages on our power supply section. And so I think if you're ever going to fix something, guys, one of the first places you should check out is the power supply section and ensure that you're getting the correct voltages to the rest of the unit. And so I've said it before and I'll say it again, if you start with crap, you'll end with crap. And so before you start diving in and trying to fix other problems, we need to make sure that our foundation is correct. And that starts at the power supply section. So that very first thing we did is we checked all the voltages on that power supply section, and we were getting good voltages. And then I went ahead and rebuilt that power supply section with new transistors and capacitors. And we were going to do that regardless, but like I said, we need to make sure we had a good foundation. Once we've done that, guys, like I said, we were able to see visually that these resistors here, these three resistors, were burned up in our amp board. And so we kind of got lucky, because not always are the problems so evident, or, you know, hey, look at me, you might want to look over here. You know, we don't always get that in electronics. So we got kind of lucked out there. So when I looked at that, guys, I want y'all to realize that my train of thought went immediately to the output transistors. And so I called it on the video. I said, hey, more than likely, one of these have shorted out or gone bad to cause that kind of damage. Because that's from excessive current, guys. So if something shorted out, a lot of current went through these resistors. They're not rated to handle that kind of current, and they started cooking. So from there, I said, you know, guys, we'll check those, but sometimes they cause the driver transistors to go bad as well. And these are the driver transistors here. So these are our outputs up here. These are the resistors that went bad, and these are the driver transistors. So the very first thing we did, guys, is we pulled out the heatsink and we looked at these output transistors, and 3 of the 4 were bad right off the bat. So we knew we had to replace those. So we did that. After we did that and we replaced these resistors, making sure we had the correct wattage resistor, as we talked about previously, we turned it back on, and we still had a short somewhere in the circuit because these resistors started to become too hot. So it didn't indicate on the dim bulb tester yet, because since these were new resistors, they were still working as resistors and limiting the current, and that's why they got excessively hot. But if we'd allowed it to stay on for a long period of time, one of these would have went open and it would have shorted out completely and cooked the rest of our components. So after turning this off, guys, I said, hey, the immediate suspects are going to be these driver transistors. So then it didn't matter, because we were going to replace these anyways, remember? Because on this amp board, we were going to replace all the transistors on all the electrolytic capacitors, no matter what we found. So I went ahead and started that process, and in the process of doing that, I discovered that both of these driver transistors were shorted as well. And so more than likely, that was the culprit that was causing the rest of the circuit. However, it could not have been. It could have been something else as well. So once we replaced those and finished our restore process on this board, we got relay click, and then you guys saw subsequently that when we put the output transistors in there, we got music. So this amp board is in good shape. But I want to talk about what would have happened if maybe that didn't fix the problem. So maybe we found these shorted and we still had a short somewhere, excessive current draw. What would I have done then? And so looking at the schematic, guys, we know that these resistors here were burned out. We know the output transistors were burned out, and we know the driver transistors were shorted out. So what I would have done, guys, is I would have looked at the rest of the circuit and seen what's connected to all these. And I would have probably checked this diode here. I would have followed the path to where these resistors go, and they go to the emitters of both of these transistors. So going from there, I would have followed it up, and then I would have checked these resistors up here on the circuit as well, leading to the output transistors. So that's probably what I would have done next if this hadn't fixed the problem. But that's all we do, guys, is we start kind of at the back end of it, and we just work backwards until we find the problem. And sometimes it can be very frustrating, guys, so just be patient and be methodical with how you test your components. One of the things I do when I get to a point where I can't figure something out is I'll print an extra couple copies of these, and then I'll start testing the components, and I'll just put an X on it once I've tested it. First I'll circle the ones that I'm kind of curious about, you know, that I think may be the culprit, and then I'll start testing. And then sometimes, guys, you know, you wind up testing half the board, and it's the one thing you didn't test that you probably should have tested right off the bat. That was the problem the whole time. So I hope me rationalizing my troubleshooting process, guys, has added some value to you guys for this video, so that you are confident when you're trying to diagnose or troubleshoot a problem on your own. Maybe it's with the 950 or with another receiver, because really this train of thought can be used with any of them. So I hope you guys found value in that. If you did, please leave a comment in this below. If you have questions, guys, or curious of what my train of thought was or why I did what, leave a comment down. And if you guys just want to say hello, leave a comment down there too. So as always, guys, I really appreciate you guys tuning in and watching these videos, and we'll go ahead and see you on the next one. Have a good one, guys.